Hello, my name is Jason Papachan. I work in Christ University. Today in this video, I would like to introduce you to the basic concepts of single sign-on or SSO. Picture this, you are working with 5 different applications and every single one asks you to log in again and again. Very frustrating, right? That is a multiple system, multiple login problem. Now imagine logging in just once and instantly moving between all your applications without ever typing your password again. That's the power of single sign-on with the key clock. Here is how it works. You log in once into key clock. Key clock verifies who you are, and if everything checks out, it gives you a secure token. Every application connected to key clock trusts this token, so whether it is your email, your ERP or your portal, you are with a single click. And here is the secret. The browser session or cookie, once you are authenticated, that cookie is like a digital glue that lets key clock remember you as long as you stay in the same browser. The result, smooth, seamless access across all systems. No more juggling usernames, no more relogins. With the key clock SSO, you get speed, security and simplicity all in one login, one identity, one trusted token, one smooth experience. That is how the key clock make multiple systems things fast. Now that we have understood the basics of SSO, let's move into the actual key clock setup and see how it works in practice. The first step is to create a realm. Think of a realm as a security boundary, almost like a container where all your users, applications and roles live. In my demo, I have created a new realm called my realm. All the configurations we make from here on will belong inside this realm. Next, we add our clients. In key clock, a client usually represents an application that wants to use key clock for login. I have created 2 clients, my app 1, my app 2. Each client can have specific roles defined within it. Roles are like permissions or access levels. For my app 1, I created the role editor and manager. For my app 2 also, I created the 2 roles editor and manager. When I assign these roles to applications, I can decide which role should be given to which user. This way, different applications can enforce different access policies, all managed centrally in key clock. Now let us move into users. I have created a user called my user, but just creating a user is not enough. We need to decide what this user can actually do, and that's where the role mapping comes in. For my user, here is how I map the roles. In my app 1, the user has the editor role. In my app 2, the same user has both editor and manager roles. This means that when my user logs into my app 1, key clock will include the editor role inside the secure token. And when the same user logs into my app 2, the token will carry both editor and manager roles. The applications can then read these roles and decide what features to allow or restrict. This setup shows the real strength of key clock. Instead of creating separate user accounts and passwords inside each application, we have one central identity, one login and role-based access control applied consistently across all systems. So to recap, we created a realm called my realm. We registered 2 applications, my app 1 and my app 2. We defined roles, editor for app 1 and editor plus manager for app 2. We created a user called my user, and finally we mapped this user to different roles in each application. With this setup, whenever my user logs in through key clock, the SSO process kicks in. Key clock authenticates the user once, attaches the correct roles in the token and allows seamless role-based access across multiple applications. And that is how simple and powerful it is to configure single sign-on with the key clock. Now we will see the actual demo. We have configured to applications in Keycloak. Correspondingly, I have created two applications here. My App 1 Frontend, My App 2 Frontend. Both frontends are built using React.js. The corresponding backends are Node.js servers, server 1 for My App 1 and server 2 for My App 2. Let's start the applications. I run the first backend, Node server 1. Then the second backend, Node server 2. Now I run the front ends. npm start my app 1 front end. Similarly, the second app, npm start my app 2 front end. Let us open my app 1 in the browser. I haven't logged in yet, so let's do that. I type in the username and password. Keycloak authenticates me and I am now logged in. My app 1 receive a token from Keycloak which includes my editor privilege. Now let us switch to my app 2. Notice I am already logged in. This is the single sign-on in action. Let's go back to my app 1. Here I have two buttons. One require editor privilege and one require manager privilege. When I click on the buttons, the button that require manager privilege fails. The button that require editor privilege succeeds. Now let's go to my app 2. As you may remember, we have associated both manager and editor roles for this user in Keycloak. So when I click the buttons, the button that require manager privilege succeeds. The button that require editor privilege also succeeds. This demonstrates how Keycloak SSO handles authentication and role-based authorization across multiple applications seamlessly. And that essentially is the main concept of this demo. This type of authentication is called user account-based authentication, where the user has to enter a login and password. There is another type of account called a service account. This is mainly used for service-to-service API calls. Service account use Keycloak issued credentials instead of a username and password to authenticate. All the code used for this demo is available on GitHub. The link is also provided in video description. I hope this session give you a brief overview of Keycloak SSO and role-based authentication. Keycloak can also access Windows Active Directory using user federation option, which makes it very powerful in enterprise environments. There are many other advanced features as well which we can explore in a future video.